Now we are going to study the energy pyramid. Each level in the food chain is called a trophic level. A trophic level is the state at which the organism obtains its food in the chain. The amount of matter and energy gradually decreases from produced at lowest level to top consumers at the highest level. Observe the figure. In this, we are able to observe at the bottom of the pyramid, all producers are present. The producers are nothing but the plants, and plants are more in number in ecosystem. Every food chain begins from the producers. So producers are nothing but the plants. That's we are able to observe in the diagram. Producer is acts as a food for the herbivores. So herbivores is the first trophic level. Herbivores acts as a food for the carnivores. Carnivores is the second trophic level. And carnivores is acts as a food for the omnivores. So omnivore is a third trophic level. So we are able to observe here the energy gradually decreasing from bottom, from producer to the omnivores. Producer to the omnivores, energy gradually decreasing. So in the producer, more in number. So energy is stored inside the plants is more. The number of herbivores comparatively to the producer is less. The carnivore is less comparatively to the herbivores. The omnivore is less comparatively to the carnivores. The energy is gradually decreasing from producer to the omnivores. Observe the figure. Figure shows the energy transfer that takes place at each trophic level. There are different levels of energy exchange in the food chain. The initial quantity of energy goes on decreasing at every level of energy exchange. Similarly, the number of organisms also decreases from the lowest level to the highest level. This pattern of energy exchange in an ecosystem is called a pyramid of energy. After the death of apex consumers, their energy becomes available to the decomposers. Fungi and other microorganisms decompose the body of dead animals. They are called decomposers. In the process of obtaining food from the remains of organisms, decomposers convert them into simple carbon compounds. These substances easily mix with air, water, soil, from where they are again absorbed by plants and incorporated into the food chain. If you observe the figure, we are able to conclude phytoplanktons 10,000 kilocalorie energy is stored. Phyta means plants, zoo means animals. So the phytoplanktons acts as a food for the zooplanktons. The energy stored in the phytoplankton is 10,000 kilocalorie. But transferred. Zooplankton is stored the 1000 kilocalorie energy. Zooplankton is acts as a food for the fish. So if the energy transferred from zooplankton to the fish is only 100 kilocalorie energy, where is the 900 kilocalorie energy? In fish body, 100 kilocalorie energy is stored. If fish acts as a food for the human, then 100 kilocalorie energy should be transported to the human body. But only 10 kilocalorie energy get transported to the human body. Where is remaining energy? So my dear children, it's a big question. If the 10,000 kilocalorie energy is stored in the plant body and the plant is eaten by the zooplankton, herbivores, then 10,000 energy should be transported, but only 1,000 kilocalorie energy get transported. Then remaining energy, 9,000 kilocalorie energy, the plant will use for its own work. Okay, the remaining energy, the plant will use for its own work. We know that energy is nothing but the capacity to do the work. So if the plant want to do the work, plant needs the energy. Which work the plant will do? Plant will do the process of photosynthesis. Life processes needs the energy. Life processes needs the energy. Plant is living thing. So plants will need energy in the process of photosynthesis. Plants need energy in the process of transpiration. Plants needs energy in many other life processes. That's why in place of 10,000 kilocalorie energy should be transported to the herbivores, only 1,000 kilocalorie energy get transported. I hope so. The concept is very clear. Sun is the most important source of energy in any ecosystem. Green plants of the ecosystem store some of the solar energy in the form of food. Green plants of the ecosystem store some of the solar energy in the form of food. Before reaching the decomposes, this energy is passed on from one tropic level to the next tropic level. Decomposes dissipate some amount of energy in the form of heat. However, no part